Let's get rid of PBS. Those lousy Muppets have been taking food out of my mouth for too long.
I say we crack down on the hippies. Blah.
What about this dang environment? Back in Texas, we got rid of it, and it made everyone a lot happier. We were so happy to get rid.
Excellent. We shall destroy the environment by scrapping every anti-pollution law. Now, Bob Dole will read from the Necronomicon.
Isaac, Gazuri, Galaneth, Maledictu, Nosferamus, and Principe. In addition, the administration has declared recycling a felony, and Smokey the Bear is now Choppy the Lumberjack.
These trees are our national heritage.
A grizzly bear with a chainsaw. Now there's a killing machine.
Good Lord, acid rain!
I'm singing in the rain, just singing in the rain. What a glorious feeling! Ah! It burns like a Glasgow bikini wax! Ah!
We better stay.
Happy Wednesday, Limerick Science students. I realize this isn't the best time to be looking at some less than happy imagery, but that's what we're up to, unfortunately. The next and last few things we'll see in this chapter relate to human impact, and unfortunately we haven't really been that great to the planet around us. We're going to go through a few things each day, topics that are of concern, but most of them are problems with pretty reasonable fixes, and some are things that we've already taken big steps to solve, so let's not go into this thinking everything is awful. I want the takeaway from these next few days to be the same as it should be for what's happening in the world right now. Sometimes there are people who don't want to hear the truth from smarter individuals who know what's actually going on. But most everyday folks have enough common sense to see how to make things better for everyone. And by working together and finding solutions, we'll get through this. It's kind of the only choice we have, right? Right? Let's begin. Acid rain is something you've probably heard of at one point or another, but most likely you're not familiar with it as part of your regular life, which is a really good thing. In this picture, you can see elements of the water cycle that we looked at recently. We've got plants and rain and a stream. The big difference is this first part on the left here, where these chemicals are going up into the atmosphere. That's from fumes, from many different industrial processes, exhaust, waste from trucks and these buildings here. People put these things into the air, and now we have to deal with the results, unfortunately. When the acidic compounds are released into the air, they easily mix with water vapor and clouds that are already there. So this causes the chemicals to come back down to Earth as part of the rain, and as the title would indicate, this rain is acidic. The chemicals enter ecosystems and can kill living things like animals and plants by messing with the natural balance of environmental conditions, nature's homeostasis. The effect is an overall loss of biodiversity, which is a phrase that we're going to see over and over again. Diversity means differences, and biodiversity means a diversity of living things that interact with each other. Biodiversity is really good and really important, so a loss of this diversity of living things can be really, really bad for an environment's continued survival. But why and how? Well, most things don't really like acid because it tends to, kill stuff. Death is about as big of a disruption to homeostasis as you can get. Plants and animals dying means the whole overall ecosystem is thrown out of balance. I should clear something up, though, and that's that acid rain is not like in the Simpsons clip from a couple minutes ago. That was overdone for comedic effect, so the clothes wouldn't burn off of people. It wouldn't be that severe of an immediate thing. Living things could be hurt pretty quickly if they're suddenly exposed to acidic environments, but it's more about the change to the ecosystem, a slightly longer term thing usually. We could see stuff like rusting cars and typically damage to statues, especially on things like the ears and noses of people statues. But this is more of a gradual erosion over time, and not a sudden thing like you saw where clothes are being burning off or the statues are going to melt or things like that. The good news is that we've known about this for a real long time and have taken big steps to reduce emissions in cars and factories. So it's still a problem in terms of some parts of the ecosystem, but at least some of these chemicals are not as worrisome as they used to be. Factories now have ways to catch the bad emissions as they're coming out of the buildings, and we see a lot more of a movement towards cleaner cars and cleaner energy sources than we did in the past. Next up, we have eutrophication. That's a word you very likely have never seen before. It's kind of a weird word, right? Anyone ever see anything that looks like this picture here? Why does this water look like someone rinsed out a bunch of paintbrushes? That's just gross looking, right? You wouldn't want to go in this water. That's really kind of nasty looking. This happens when fertilizers or sewage get dumped into water, which results in a lot of extra nutrients suddenly being available for algae in the water to feed on. So when this happens, the algae grows out of control and uses up all the oxygen in the water. What's so bad about that, you might ask? Well, living things tend to like oxygen. They need it to survive in most cases, right? When there's not enough oxygen around, they die. So the algae using all the oxygen creates what are called dead zones, where the rest of the plants and animals in a lake or pond or one of these aquatic ecosystems run out of the air they need to breathe. And that's often dissolved oxygen, not the oxygen in the air around the pond. It's the oxygen that's actually in the water that the fish would use and other plants like that. So this again causes a loss of biodiversity. Like I said, we're going to see that all the time. All these things are going to add to a loss of biodiversity. It causes a lot of living things in the ecosystem to die. Once again, we know how to fix this. We can treat waste before they're dumped into the environment, so we have waste treatment plants, and we can try to reduce the use of fertilizer. There's a big difference between using manure or compost, other natural things to make plants grow better, and using chemical fertilizer that dump a lot of unnecessary chemicals into the ground and eventually into the water and ground systems. So by cutting down the more extreme and artificial products, it can have a really positive impact on the environment around us. Okay, last one for today, and this is going to be a little bit similar to what you just saw from eutrophication. What do you notice in this picture? I see a little plant here down near the left. I see a couple of small fish and then some larger ones. This looks a little bit like one of those food chains we saw recently, right? But what else do you notice? What's inside of all these plants and animals? Something labeled up at the top here. And that's probably not something we really want a lot of in the ecosystem. We can help it, right? It looks like we have some DDT in this ecosystem. And just so everyone is clear, this DDT is the chemical pesticide that farmers sometimes use to kill insects, and not the finishing maneuver of wrestling legend Jake the Snake Roberts. In case anyone's confused by that, just want to set the record straight there. So what's going on here is an example of bioaccumulation or biomagnification. I'm going to give you this word bioaccumulation here, and then the next slide I'll use biomagnification. So it's just the same word, same meaning, it's just interchangeable. Magnify means to make something bigger, right? Like a magnifying glass. So this biomagnification is when the amounts of chemicals get bigger as we move through an ecosystem and up a food chain. So let's see how this works. So I mentioned biomagnification is a little bit similar to eutrophication. And biomagnification starts when chemicals, especially heavy metals like mercury and different poisons like weed killers and pesticides, are introduced into the environment. So remember how animals higher up the food chain need to eat a lot more food to stay alive? So there's always more of the plants and the zebra at the bottom of the food chain than the lions at the top of the food chain who eat those things? Well, that kind of idea comes back here. The chemicals go into the water, seen as some dots in the bottom of the food pyramid here. So we see a couple of these. Let me change my color. We see a couple of these little orangey dots near the bottom, but not that many. When small animals then drink the water, or plants that grow in the water, the chemicals start to build up more in their bodies. So by the time you get to the top of the food pyramid, the biggest animals have a lot of these chemicals in them, and this can be very harmful. We see getting a little more concentrated here with the producers, the plants, and there's a little bit more concentration here. Think of it just even as these kind of boxes, these little areas get smaller. So those same chemicals are more compact and more packed in there. So you get more and more of them built up as you get up the food chain. We see here a measurement of all this. If you only have one chemical here, and then there's 1,000 and 10,000, it keeps increasing by factors of 10. By the time you get up to these birds at the top of the food pyramid, there's a whole lot of that chemical there. So that's really not great. If you've ever heard of pregnant women not eating some kinds of seafood, this is the reason for that. As I mentioned, mercury contamination in sea life is a problem, and that can be especially dangerous to a developing fetus. So a lot of times pregnant women will be told, don't eat sushi, don't eat this kind of fish, don't eat something else like that, because it can be potentially dangerous. Not necessarily, but it is a risk. So this is the same loss of biodiversity risk as everything else, but also clear solutions. So if we just use fewer chemicals in the environment and do a better job of not just dumping them in the first place, then we can also use natural predators instead of toxic pesticides. Ladybugs may look cute, but they are vicious killers of the animal kingdom. Snakes and spiders also do a great job of keeping unwanted bugs from crops, but you can imagine why farmers might be hesitant to have a few hundred acres of land filled with snakes and spiders. So again, we don't need all these pesticides. We don't need all these chemicals being dumped in the environment. Yeah, it helps us, but I mean, historically speaking, people never use this until really the second half of the 20th century. This is a fairly new thing. And now suddenly we have to kind of pay the piper when these chemicals come back to bite us again. So yes, they're very helpful for us. They help us run businesses. They help us get the ability to grow lots of crops all the times. but they are also very dangerous, and we have to be really, really careful how we're doing these things. So just a quick side note. I had a friend in college who was afraid of ladybugs for some reason, so I used to collect them whenever I'd find them around and put them on her bed because it was really funny. It was also pretty mean, so don't do that. That's not something I want to encourage. But I also didn't realize at the time that ladybugs can be purchased by the thousands from any garden center or even on Amazon, and they really don't cost that much money. So if you ever want to buy a couple of thousand ladybugs at a time, it only costs about $25. Probably shouldn't tell you that, but be nice to each other. Definitely don't do that to anybody. Once you're back in school, though, someone make sure to remind me about my other ladybug story because I think it's good. Yeah, I'm with you, Ari. That's it for today. Go fill out today's form right now. Email me with any questions. I'll talk to you tomorrow.